All right, welcome back. Let's talk data types. But first, let's talk memory. So in memory, your junk is all stored as ones and zeros. It's all stored as electricity, as either an on or an off. And so each bit is either on or off. It's a 0 or 1. And a byte is a collection of 8 of these bits. So we can actually count in basically base 2 with our bytes. And so a decimal 53 represented in base 2 looks like this. That's how it would be stored in memory. For 10, it's just a 1010. So these are like, this is the ones place, the twos place, fours, eights, 16, whatever. And so 2 plus 8 is 10. For this one, it's 4 plus 16 is 20. And you can see that adding a 0 at the end increases it by 2, or multiplies it by 2 the same way as throwing a 0 on the end of a decimal number multiplies it by 10. So 1 byte can hold up to 2 to the 8, which is 256 values. 4 bytes can hold over 4 billion. If you're doing signed numbers, you can go -2 billion to +2 billion. Same with like a signed character or signed just a single byte. You can go -128 to +127. Let's go ahead and look at our hello world. Whoops, nano hello world. And go ahead and play with some variables real quick. So we'll say like integer number equals 16. There's also floating point numbers. Actually, we'll use double. Double is the same as a float, only it's a little bit more space. And so it's a little bit more precise. It'll double the precision of a float. We'll say that's 16.0. There's also chars that we've kind of looked at. So you'd say like char letter equals. You use single quotes for these for character, whereas if you did an array of chars like word and say it's 20 characters, you could do string literal with 2 things and like blah blah blah, it's whatever. We'll get into arrays and pointers and all that next time. But basically right now I kind of want to make the distinction that these integers and doubles, they kind of handle things differently. So if we go num equals num divided by 3, it'll divide 16 by 3 and reassign it to number for us. We'll do the same thing with num2 equals num2 divided by 3.0. And then instead of printing hello world here, we will say value equals, we'll start with our digit, %d, and we will feed the print format function number for that %d. It'll throw it in there and it'll print for us. So let's look at what that does. Whoops. GCC to compile. And then run it with /a.out. Value equals 5. So 16 divided by 3 equals 5. And what happens there is it takes the number of times that 3 goes into 16 as a whole number, and it gives us that. Now if we were to print num2, and we tell it %f for a floating point, not a digit, go ahead and recompile that, and rerun it, and there we get the actual decimal value. So you can use integer division for some crazy stuff. It's pretty handy, but you have to realize that there's pitfalls with it. There's also a modulus function, which is just the remainder. So I could say something like int a equals, that's 16 again, and then int remainder equals 16 divided by, oh wait, %3. I will go a. I don't know why I did that. So this will take a, which we have assigned 16 to, and it'll divide it by 3 and find the remainder. It'll find the modulus 3 of 16, get the digit, and we'll print out remainder, and it should give us 1. All right. So that's the basic data types in C. Next time we'll go over some crazier stuff, arrays and pointers, and then running through it, things that you can do with it, and all of that.